Hey! Welcome to math class where math makes sense. That's the goal. Welcome to math class where math's our friend. Feel the math love! Synthetic division. Here is a polynomial divided by a polynomial. When can we use synthetic division? That's baked into our song, and it's a way to just quickly divide using the coefficients as opposed to doing a whole long division process. Here's the song. Synthetic division is an easy abstraction. When you divide by a linear, it's linear, with the leading coefficient of 1. It's linear and the leading coefficient is 1. Count your degrees to the fourth, to the third, squared, to the first, constant. And if 1 is missing, you put a 0 there for the term that's not there. Is there any missing term? 4, 3, 2, 1, 0. No. So we don't need any 0 placeholders. I'll do one with a 0 placeholder next. Okay. So we go ahead and write down our coefficients, okay? The 0 goes in the house. There's a little house over here. The 0 of my linear that I'm dividing by, that goes in the house. The 0 is -2. Now remember, with long division, you do the whole process, and at every step you subtract to figure out what's left over, right? The subtraction is basically baked into the synthetic division process because we're using the 0. Okay. The 0 goes in the house. Drop your first term down. There we go. Drop the first term down. Multiply and combine. Be sure to watch your signs. So we multiply. -2 times 3 is -6. And combine. All right, multiply and combine. We're going to multiply again. -1. Multiply again. +2. Be sure to watch your signs. 1. Multiply by again. -2. Okay. Multiply and combine. Be sure to watch your signs. If a 0's there. My daughter's trying to get my attention. Hi. Multiply and combine. Be sure to watch your signs. If a 0's there, you have a factor. Okay. Because the number there is your remainder. This is your remainder. If the remainder is 0, it means that this is a factor of this. So what can I now write? I can say that this quartic polynomial divided by this linear is equal to, that's actually equal to what's left over here. All right, I divided a quartic by a linear, so I'm left with 3x. I'm left with a cubic. No squared term, -x plus 1, and a 0 remainder. So this quartic divided by this linear is equal to 3x cubed minus x plus 1. Those are equal. This statement is equal to this cubic. Okay. What happens if we don't get a remainder of 0? What happens if we've got some of those placeholders? Let's do another example. Can I use synthetic division? Let's ask. Synthetic division is an easy abstraction. When you divide by a linear with the leading coefficient of 1, I can use synthetic division. Count your degrees, and if 1 is missing, put a 0 there for the term that's not there. Third degree is missing. Second, a first degree is missing. 8, so we need 2 placeholders. 0 goes in the house. The 0 is 1. Drop your first term down. Multiply and combine. Be sure to watch your signs, or repeat and watch your signs. Repeat. -1, -1, repeat. -1, 7. If a 0's there, you have a factor. Okay, this is not a factor of that, because the number there is your remainder. That's my remainder. Okay, so now I can write that this quartic divided by this linear is equal to, how do we write this now? Again, quartic divided by a linear is going to leave me with a cubic. We always subtract 1 degree there. So this is 2x cubed plus 2x squared minus x minus 1. That's the cubic I'm left with. This divided by this is going to be equal to that cubic. And then we got to use our remainder. And we say plus 7 over the x minus 1. That's how remainders work. You get your quotient plus the remainder over that original divisor. So please subscribe, like, share, follow, stream Synthetic Division, which can be found on Funky Functions, anywhere you get your music. And remember, math loves you. Bye.